Everyone, welcome back to the Compact YouTube channel. So in this video we are going to discuss some functions questions asked in IIT JAM Economics 2022 question paper, right? So let's start with the first question. This is question number 53, and here we need to find out the integral I, that is t times logarithm of 1 plus 2 by t into dt, right? And they have given a specific form, like in which form this would be, and then we have to find out the value of constant k, right? Okay, so first we know, like, it's a basically a product of two different functions, and then we have something called the isolate rule, right? So in the according to this rule, the logarithm will be considered as the first function, and the t, which is simply an algebraic function, is considered to be the second function, right? So we will use the integration. So it will become like the first function. Let me write the formula first. First function as it is, and the integration of second function, right? And the negative of integration of derivative of first function. So d over dt of first function into integration of second function here, and the total integration, right? So let's use this formula. So the first function is logarithm of 1 plus 2 by t will be as it is. Then we have the derivative integration of t is nothing but t square by 2, right? Minus integration of the derivative of first function. So when we see the derivative of first function, so we know the derivative of logarithm is like 1 upon 1 plus 2 by t. And using chain rule, we will have the derivative of 2 by t as well, which is coming out to be minus 2 upon t square, right? And the integration of second function is nothing but t square by 2 and this dt, right? I hope this makes sense to all of you. So we have like a logarithm of 1 plus 2 by t as it is, and then this is like t square by 2. Then we have negative of, so I can I like this, from this t square, this t square is cancel out, 2 to 2 cancel out, and this negative will become the positive here, right? Positive integration of, can I say this as t upon t plus 2 and then dt, right? So this further can be rewritten as logarithm of 1 plus 2 by t will remain as it is. Then we have like t square by 2, and then I can write it down this integral as like t plus 2 minus 2 divided by t plus 2 into dt, right? So this will be rewritten as like logarithm of 1 plus 2 by t into t square by 2, and this is coming out to be integral of 1 minus 2 upon t plus 2 into dt, right? So let's do the integration. So let me write it first one as it is, log of 1 plus 2 by t into t square by 2, and then we have the integral of 1 is simply t minus 2 times integration of 1 upon t plus 2 is nothing but log of t plus 2, right? And we can have like some plus some constant, say c. Okay, so this is like how our integral will look like. Now let's but this is even like right now it's not in the form that in the required format, right? It should be like t square by 2 minus 2 plus ft t square by 2, something like this. Okay, to convert into that form, so just see here, like we have log 1 plus 2 by t, which further can be written as log of t plus 2 by 2, right? And I can further rewrite this as log of t plus 2, sorry, upon t here, minus log t, right? So we will use this one particular property of logarithm, and therefore this can be written as like log t plus 2 multiply by t square by 2 plus, sorry, not negative, log t multiply by t square by 2 minus 2 log of t plus 2 plus t plus c, right? So this further can be written as like log t plus 2 times t square by 2 minus 2, right? And then we have plus of minus of log t times t square by 2 plus t plus c, right? So if you compare this like the final form with the given format, we can say that gt is nothing but log t plus 2, right? ft is nothing but negative of log t, k is nothing but 1, and c will be c, right? So the value of 2k will become like 2 times 1, which is coming out to be 2. So 2 is the correct answer here, right? Okay, so let's move to the next one. That is question number 44. Okay, so given that the function fx is of the form of a times of x plus b, and with the condition that a plus b is 4, so I can say that like f of 1 is nothing but a plus b, right? And this is given to be 4 to us. And one more condition that given to us is like the value of f of x plus y is nothing but f of x plus f of y minus 2, and for all choices of x belongs to real number, right? So can I put here like let's say x is equals to 0 and y is equals to 0. Then we have f of 0 is nothing but like f of 0 plus f of 0 minus 2, right? So using simple algebra, we can cancel out like f of 0 to f of 0, and we simply have like f of 0 is equals to 2, right? So we have f of 1 is a plus b is 4. Also, like if I put value of x is 0 in fx, we know that like f of 0 is nothing but a times 0 plus b, which is simply b. So value of b is 2 here. And then from this one particular equation, we can find out the value of a. A is nothing but like 4 minus b, which is 4 minus 2, and again coming out to be 2, right? So, therefore, I can say that the value of fx is nothing but 2 times x plus b, right? And so this implies the value of summation n is equals to 1 to 50 f of n. So this will become like summation n is equals to 1 to 50, 2 times of n plus b is also 2, right? So let me write 2 here. Okay. So I can say that this will become like 2 into summation of n is equals to 1 to 50 n, right? Plus 2. Okay, so like the 2 is a constant here, right? And we have to add the constant value 50 times. That's what like summation n is equals to 1 to 50 means. So I can say that like summation n is equals to 1 to 50 of 1, right? So it will simply add 1 at 50 times. Okay, now we know the formula. What is the formula of summation n? This is nothing but like n times of n plus 1 by 2, right? And here the maximum value is 50. So this will become like 2 times 50 times 50 plus 1, and that's divided by 2. Plus this will become like 2 times 50. So I can cancel out 2 to 2. So this is nothing but like 50 times 51 plus 100, and this is coming out to be 2550 plus 100, which is nothing but 2650, right? Okay, so let's move to the next question. So question number 38, and the ask is which of the following functions is are homogeneous, right? So first let me define what do we mean by the homogeneous function. So a function of like two variable x and y is said to be homogeneous if the degree of each term is same, right? Let me write the same thing. A function fxy is said to be homogeneous if the degree of each term is same. So what do we mean by like the degree of each term? So for example, if we have a function fxy like this, 3x square y plus x power 3 plus y power 3. Clearly, this is a homogeneous function because degree of this term is 3. Degree of this term is 3. And again, degree of this term is also 3 because here we have like 2 power of variable x and 1 power of variable y. So in terms of like variable, the power will become 2 plus 1, that is 3. Right? So such function is simply called as homogeneous function. Now, if it is a homogeneous function of degree n, that simply say I can take like x power n outside, right? So fxy can simply be written as like we can take x power n outside and we have like a function of y upon x in this case. So this is also a homogeneous function. And by the same way, instead of like x power n, I can also take y power n outside and we have g as a function of x upon y. And this is also a homogeneous function, right? So let's using the same properties, let's check it out the first one, right? So here, this can be written as x power 1 multiplied by some function in terms of y upon x, right? So that simply means it is a homogeneous function of degree 1, right? So this is a homogeneous function. Make sense? Again, here I can say that this can be written as x power 0 times square root of x upon y plus 3 times of x upon y plus 7. That is a some function of x upon y, right? So and here is a point here. So when we say like it's a function of x upon y, so instead of x power 0, let me write down y power 0 here. That will make like a job easier for us. So y power 0 and it is a function of g of x upon y, and that simply means again it is a homogeneous function of degree 0. Now let's come to this one. So here we have like x power 3 plus y power 3. Okay, so it's like a numerator upon denominator kind of a function, right? So whenever we have like a numerator upon denominator, rational function basically, then this is said to be homogeneous. So is homogeneous if both numerator and denominator are homogeneous function, right? So here we can see that like numerator is a homogeneous function of degree 3 and denominator is a homogeneous function of degree n. So the rational function is also homogeneous here, right? Okay, the D. So here you can see that the first term have the degree 6, right? X power 5 into y. Second term also have degree 6, x power 2 y power 4. But the third term have degree 7. That means it is not homogeneous function, right? So here option A, B and C are only A, B and C are correct, right? So D is not correct. Always remember like homogeneous function means degree of each term should be same. Okay, so let's check it out the next question, that is question number 34. Okay, so here we have like f of x is given in terms of modulus of x, right? Plus modulus of value of cos pi by 2 minus x. The modulus of like the complete thing, and then x belongs to nothing but like minus pi by 2 to pi by 2. So first of all, like one simple point here for x, like we know that this can be written as like a positive x if the value of x is greater than and equals to 0, and obviously less than pi by 2 because this is our domain here, right? And it is going to be negative of x if the value of x is between minus pi by 2 and 0, right? But for cos pi by 2 minus x, if we can see that the value of okay, so the point here is like how pi function like cos function behaves. So the graph of cos function is something like this between minus pi by 2 to pi by 2, right? but it's not simply like cos x, it is cos pi by 2 minus x, right? So when we put the value of x is negative of pi by 2, so it simply become like cos pi, and then yeah, so it simply move till here, right? So now my point here is between when we say like the x lying between minus pi by 2 to 0, so this pi by 2 minus x will become, we can say that will move from pi to pi by 2. Agree? So at like minus pi by 2, this will basically become addition, pi by 2 plus pi by 2, right? And as soon as this will start moving to 0, this will start moving to pi by 2, right? And between pi to pi by 2, it should be like yeah, between pi to pi by 2, we know that the value of cos function is gonna be negative. So whenever x belongs to minus pi by 2 to 0, I can say that the value of cos function is gonna be negative, and we have this modulus can be written as nothing but negative cos pi by 2 minus x, right? And so when x belongs to minus pi by 2 to 0. And the second case, when x belongs to like 0 to pi by 2, then this difference will start from pi by 2 and it will move to 0. And here the value of cos x is gonna be positive. So this is simply cos pi by 2 minus x, right? So that simply means I can simply divide my function fx into two parts, like the positive one and the negative one. So we have this line here. So this will become, I can say that like if x belongs to minus pi by 2 to 0. So this is coming out to be negative of x into negative of cos pi by 2 minus x, right? So whenever minus pi by 2 is less than x is less than 0. And this simply becomes like x plus cos time of pi by 2 minus x if 0 is less than equals to x is less than pi by 2, right? So obviously, like fx is a continuous function minus at minus pi by 2 to 0. This is simply a continuous function as cos x is a continuous function and x is a continuous function, right? Similarly, fx is continuous function on the interval from 0 to pi by 2. But we need to check out the continuity at point 0. So let's check continuity at 0. So to check it out, continuity at 0, we first of all we need to know what is f of 0. So this is coming out to be 0 plus cos pi by 2, which is again nothing but 0, right? So it is 0. Now let's have the left hand limit. And left hand limit. So first let's find out the right hand limit. So this will become f of x is nothing but limit x approaches to 0 plus the function should be like x plus cos pi by 2 minus x, right? So this is coming out to be 0 plus cos pi by 2, and the value of cos pi by 2 is also 0. So this is nothing but 0 plus 0 is 0, right? This makes sense. Similarly, we can find it out the left hand limit. So this become like limit x approaches to 0 minus of fx, right? So this will become limit x approaches to 0 minus and we have like negative of x minus negative of cos pi by 2 minus x, right? So this is coming out to be negative of 0. Because the limit of x approaches to 0, x is 0, right? And cos pi by 2 minus x will become negative of cos pi by 2, which is again coming out to be 0. So this is nothing but negative 0, negative 0, 0, right? So we can say that fx is continuous at 0. And if fx is continuous at 0, then we can check it out. Like then it makes sense of finding out the differentiability as well, right? Otherwise, different checking like if function is not continuous at 0, then differentiability does not make any sense. So option A is correct till now. Option D is correct. Now I need to check about the differentiability at 0. So when we say check differentiability at 0, again, because the function is defined different in left hand side and right hand side, so I need to find it out like left hand derivative and right hand derivative. So let's start with the left hand derivative. So this would look like limit x approaches to 0 minus, and the formula says this will become like f of x minus f of 0 upon x minus 0, right? So f of 0 is 0. So I can simply say that this will become like limit x approaches to 0 minus 1 upon x of, and we know what is the value like when x is less than 0. So I can take negative outside, and this is nothing but x plus cos pi by 2 minus x, right? So this is coming out to be nothing but like limit x approaches to 0 minus, and this will become like negative of 1 minus cos pi by 2 minus x divided by simply x, right? Now, the negative one is not the problem, but cos pi by 2 minus x, whenever we put x is equals to 0, this simply become cos pi by 2, which is 0. So this is somehow like 0 by 0 form, right? So I can write it down, this is nothing but like negative 1 minus limit x approaches to 0 minus, and we have like cos pi by 2 minus x divided by simply x, right? 0 by 0 form. So we will apply L'Hopital rule here, and this will become nothing but negative of 1 minus limit x approaches to 0 minus, and we need to differentiate both numerator and denominator, right? So our denominator simply become 1 because the derivative of x is 1, but the derivative of cos is coming out to be negative of sine, and then the derivative of minus x is coming out to be negative of 1. So this somehow become like positive of 1, right? So when we put x is equals to 0, so this will become like negative 1 minus sine pi by 2, right? And the value of sine pi by 2 is nothing but 1. So this is coming out to be negative 1 minus 1. So this is coming out to be negative of 2, right? So here left hand derivative is negative of 2, but we know that like the function on right hand derivative is not, is the same function, right? The only difference is of this negative sign. Like the left hand side have the negative of like whatever the function we have, and so it like x plus cos pi by 2 minus x whole multiply with the negative sign, and right hand side is the simply x plus cos pi by 2 minus x. So if we apply the formula here, we try to find it out the right hand derivative. So the value of right hand derivative is coming out to be positive 2, right? You can apply the same rule, just the same thing, right? So I can say that here the left hand derivative is not equals to right hand derivative, and if left hand derivative is not equals to right hand derivative, that simply means f is not differentiable at 0. Right? So f is differentiable everywhere except x is equals to 0. So option A, C, and D are correct here. Right? Okay, so let's move to the next question, which is question number 13. Sorry. Yeah. So let's move to the question number 13 here. So in this case, we given a function f of x in the form of like x plus 1 upon x plus 2 for all x belongs to real numbers, right? And we need to check it out whether the given function is 1 1 or on 2. Okay, so to check out whether the given function is 1 1, we simply use the derivative test. Let's first find out the derivative of x, right? And we will use here the division rule if we need to find out like the derivative of 1 upon second. So this simply written as like the derivative of first multiply by second minus first as it is derivative of second and divided by the whole thing second whole square, right? So this will become derivative of x plus 1 is 1 into x plus 2 minus x plus 1 as it is, and the derivative of x plus 2 is coming out to be 1, and the whole thing divided by x plus 2 whole square, right? So this coming out nothing but like 1 divided by x plus 2 whole square, and which is gonna be greater than it equals to 0 for all choices of x belongs to real number. That means always increasing, right? And hence 1 1. So like monotone functions are 1 1 functions, hence 1 1. Now to check it out whether the function is onto, so we will simply use like let y belongs to real number, and y is nothing but like f of x, which is nothing but like x plus 1 divided by x plus 2. So let's do the cross multiplication here. Then I can say that the value of x plus 1 is nothing but y times of x plus 2, or this is like simply xy plus 2y, right? Now we can simply write down, we have like x minus xy is nothing but 2y minus 1, or the value of x is coming out to be 2y minus 1 divided by 1 minus y, right? Okay, so that means this is well defined for all choices of x, sorry, define for all choices of y except y is equals to 1. So that simply means there do not exist any real number x such that f of x will become 1. Hence, not onto, right? So here I can say that the given function f is 1 1 but not onto. Okay, so that's all for this video. I hope the solutions are making sense to all of you. Thanks for watching this video. Bye bye.